Hi, welcome to 15 for Wireless, where we take 15 minutes on Fridays to talk about trends and technology in the mobile industry. I'm Kelly Hill, tech reporter for RCR Wireless News, and I'm talking today with Scott Sumner, who is VP of Solutions Development with Accedian Networks. Welcome, Scott.
Thank you, Kelly.
Can you start us off with a brief introduction to Accedian?
Sure. Accedian's a 10-year-old company now that's specialized in performance assurance. So everything spanning turning up new circuits, new services, network layer diagnostics, monitoring, and also more recently optimizing traffic as well.
Okay. Great. Well, let's talk a little bit about some of the challenges that you're seeing in terms of voice over LTE. It's something that we've been talking about for a while in the industry. There have been a lot of attempts and a longer process maybe than was expected. So let's talk about some of the things you guys are seeing.
Yeah, we're seeing it more from the network side and the initial deployments, and being in performance assurance is interesting because they really only talk to you when things go wrong. But when you're going into a new service like that, nobody's quite sure what to expect. If you're testing these things in the lab, it works pretty well because everything's basically within range of itself. And one of the big problems, I'll just give you a quick view of that, is when you go out into a real mobile network and you're looking at small cells and you're looking at these other different topologies, really what's happening in the network is you're getting a significant increase in latency as the backhaul chain gets longer. So this is that diagram there. It kind of explains, in the past, you'd be going to like a macro tower. And so you can see that maybe this is a one-way latency measurement, maybe 15 milliseconds. But when you go into a small cell network, which is really required for VoLTE because you're going to be in the latest generation network, you could be doubled basically the latency up to, let's say, 30 milliseconds. And if you're looking at voice control for roaming, maintaining call quality, and media type streaming, which is the audio portion of it, you see the requirements on these type of things are about half of what could be typically measured in a network. This is really where the problems might start to pop up.
Wow. So how are the operators dealing with that? I mean, if that's the backhaul network and that's the situation that you have, how do you solve that latency issue?
Well, that's kind of the fun part, because one of the things that comes along with VoLTE and is kind of the big debate right now between operators we're working with is, where do we place these controlling functions? And if you look at that backhaul, you'll see that there's a data center here, which would normally be the MSC or the switching center. You got your hubs farther out into the radio access network, and then aggregation routers. And VoLTE, all the control plane mechanics, I guess you'd say, all the algorithms and databases and all the things that are handling call transition and setup and teardown, are happening in virtual machines. These are virtual network functions that rely on scalable compute resources. And the question here is, where do we put the VNFs that are going to be responsible for VoLTE calls? The media part is fairly straightforward because we've been doing voice for IP for years. It's just that now we're doing it in a mobile network. And so the choices they have as operators, the most comfortable choice for them, which they've been using for pretty much all the VNFs that they would normally remove from the edges, is at the data center that would be centralized so they can choose to scale up those resources as they need to. It's in a simple, secure location. But as we see from this latency, basically that location might not work very well if it's too distant from the customer. The end user might be too far away in the backhaul chain. So the next choice would be to put this in some sort of centralized hub that's connecting macro sites, or in let's say, a ring in a metro area that might be carrying the backhaul traffic. In those cases, that still might not be enough. If you're using indoor small cells, for example, you're going through corporate LANs, you're going through open internet sometimes as a backhaul, you're introducing an unknown amount of latency basically into your equation. As an operator, you're going to try to push those network functions as deep as you can towards the user. And this is basically the debate today. Where do we put this? This is a major problem. It's something they can't easily simulate. You have to basically go into your network and start to try these things live. That's also dependent on how much traffic is in the network, how the backhaul is being used for other things, and sharing that with other data traffic. So a lot of unknowns out there in terms of VoLTE. But if we look at the operators who have successfully deployed it, most of them are in the Asia Pacific region, South Korea, Japan, China, and they're deploying these over very dense networks, very fiber-rich, very low latency networks. There's not a lot of microwave. There's not a lot of other processing issues there. They have the the highest performance all fiber backhaul you can imagine in these cities like in South Korea. So they've had these issues, but they've been able to overcome them by prioritizing traffic. But when you get into a longer chain, it gets basically maybe impossible. So that's where we're at in the States right now. You're seeing trials at a lot of the major operators. But they're lucky at this point. There's not a lot of devices that support VoLTE. So they if there are end users who have a device, it's a small handful, and they're the guinea pigs.
Yeah. Now you mentioned some of the places where we've already seen VoLTE deployed. Can you talk about some of the lessons learned that you think will be relevant to operators in other parts of the world? Obviously, the speed and the architecture of the network in terms of backhaul, is important. Are there other details you can give us in terms of some of the things that we might end up seeing in other VoLTE networks?
Yeah, I guess there were some interesting discoveries, and maybe they're about 2 years ahead of some of the more Western nations that are going to be going through this in Europe and North America. But the biggest issue, I think, comes down to network synchronization. And we were talking about latency, but latency is one issue. If the different towers and sites are actually out of sync as well, then it's with not using a common clock, the call handoffs can be quite difficult to maintain, or the margins getting very slim. When you go into LTE Advanced, which they're using for the VoLTE rollout, that is really highly dependent on extremely tight synchronization, not only in terms of the standard frequency, but also in terms of phase, which is something a lot of networks don't actually synchronize today. And when you talk to synchronization experts, you find out that introducing phase synchronization is extremely difficult. It's not something that most people are even aware of how to do. Something they have to tackle, and it's a whole new level of synchronization that has to happen over a packet network. Now, when you talk about America in particular, there's a real concern there because almost all the cell sites today are synchronized using GPS. They're not using methods, packet-based methods, or SYNC-E, or that kind of approach with master clocks approaching the edges as often. And GPS itself is just not quite precise enough for this kind of application. So it works for 4G, but when we get into LTE Advanced, you're going to see a little more concern there. So I think the combination of the latency in the network, but also the synchronization, is really going to hit not the call quality as much as is the call going to be there.
Okay. So we've talked a little bit about latency, we've talked about synchronization, and I'm wondering, just kind of in a more general sense, what implications you think VoLTE is going to have for network analytics. How operators track those things, how they get the information about the network performance, and to what extent they're going to be able to do troubleshooting and diagnose network problems, in real time or as close to real time as they can get it, to make sure that these very, very sensitive, functions are operating the way that they need to.
Yeah, it's a challenge, and when you talk to analysts today about the VoLTE market in terms of test and measurement and what people are doing, there's about I'd say there's 4 segments there that are critical, or people are attempting as companies to solve. You have the aspects of passive monitoring, where you're looking at actual traffic. You're trying to see how calls are going. You're getting call data records and call completion records, and how many calls are dropped, and so on. That kind of thing can still be done just the way it is today in a traditional 3G voice. But of course, there's different protocols. But being based still on an IMS system is pretty simple for them. But the trick here is, the end user is mobile. They have quality issues that are related to the speed of their phone itself, the different modems inside. So there's a number of companies that are crowdsourcing kind of the data collection by putting applications directly on the phone that can measure call quality and report that back, and that gives them another feeling of what's going on. if there's a large number of issues happening reported at an application layer like that, and these are basically passive devices, then you have to go to the other side of the monitoring equation and look down into the network stack and see if those things like latency and packet loss and availability and utilization, all that kind of stuff is actually affecting a large number of users. And that's often done with an active test probe method where you're actually sending, Ethernet OAM packets and you're measuring them actively between very precisely time-stamped endpoints. So a combination of tools are going to have to be deployed. What's more common today is the network active monitoring, because that's already been out there for the 4G data. So basically they may have to just add some extensions to it to calculate MOS score from the codecs. And but it's the application layer is something that's evolving very rapidly, and it's going to have to evolve quickly because there are deployments starting to roll out now.
Okay. Let's touch on one other area, and you have already mentioned to some extent some virtualization going on in certain network functions. But I'm wondering what you see as the implications for this larger movement toward SDN, software-defined networking, and NFV, and what that's going to mean for the type of analytics, the type of monitoring that's going to need to be done in order to manage the network.
Sure. No, that's a shift that we're following very carefully as a performance assurance company, and this is an illustration here of the architecture that mostly is in play with these type of SDN networks. And what's really causing the complexity here isn't just the fact that it's SDN or VNF based. It's also that the services that the customers are using are going to be essentially considered virtual, right? So I'm going to go into my cloud-based management panel, and I'm going to give myself an extra 50 megs per second while I'm doing backups right now, and that kind of thing is going to be provisioned more or less instantaneously. And that has to bridge the difference between this virtual network and a physical network, and there's a lot of interesting things that can go wrong there. I guess the other thing that's going on in terms of analytics, and we'll discuss how we can do that, is essentially you have to correlate this virtual network with the physical network. So this is the customer's viewpoint, and you can see underneath there is an awful lot of things going on. But beyond just that, VNF's introduced this interesting issue along with, let's say, hosted business services. Like I'm running my SQL server on a VM somewhere. Typically, these virtual machines have the ability to move around geographically. It's based on load balancing and time of day and geography and latency. So decisions have to be made about where those VNFs are going to be. If they're clustered, is it going to be in multiple locations? The problem here with analytics is your test points have to move with your virtual machines or with the VNFs to be accurate. So if you're going to do like a latency test between a hosted VNF or a virtual machine and a business or a cell tower, you're going to have to be able to measure to this virtual endpoint, which might be moving around. It's on shared resources. It may be traversing a virtualized network inside the data center itself. So you're getting a lot of interesting visibility issues. And I guess the other thing is, look at the OpenStack, OpenFlow, a lot of the standards in SDN, and they don't have much provision in them for performance analytics and monitoring. So they have counters, packet loss, some very simple things, but there's no provision in there to really get the full stack of metrics that network operators are comfortable with today. So I think what you're going to see is these cloud services are going to roll out. They're going to be lacking things like service level agreements because the provider really just doesn't have a way to validate performance, and neither really does the customer. And so as people migrate towards those, they're going to be demanding SLAs, of course, right? So we're going to have to find a way to instrument the network to get the analytics that actually trace the virtual network, trace the physical network, and correlate the two with some sort of network hypervisor as an intermediary. This is all evolving. I mean, it's not new that we have virtual networks. We've been using MPLS tunnels, which is basically just an abstraction of the network underneath. What has to happen now is it's going to be much more fluid. It's going to be changing much more rapidly, and the customer will have control over their own service parameters, and that's where it's going to get interesting.
Okay. Great. Well, that wraps us up for today. Scott, thank you so much for your time. We really appreciate you taking the time to have the conversation with us today.
Thank you, Kelly. So it's been fun being here.